Welcome to the Unit 3, Section 3 video on key features of functions. There are several key features that we can pick out when looking at a graph. We've already talked about domain and range. Now let's talk about some of the others, starting with end behavior. So recall, the domain is a set of all x values, and the range is a set of all y values in a function. The domain in this graph is bounded on the left, but it goes infinitely to the right in the positive infinity direction. The range is bounded by the bottom of the graph, but it is also going infinitely up in the positive infinity direction. The ends of the function are going to be either definite, meaning they terminate, or indefinite, meaning they continue forever. When the end is indefinite, as indicated by an arrow, a statement about the end behavior can be written. So, symbolically, you're going to have this, and it is read as x approaches infinity, f of x approaches infinity. So as x, so that's so far it's read as it's written symbolically. The arrow is used to indicate the word approaches infinity. F of x approaches infinity. Okay, so really the only thing to really learn here is that the arrow is a symbol for the word approaches. If both ends are indefinite, there will be two statements, one for x approaching infinity and another for x approaching negative infinity. And we're going to do some examples so you can see how this works a little bit later. The next key feature are the intercepts. So the x-intercept is the value of x when y is 0. It is where the function crosses the x-axis. So the y-intercept is the value of y when x is 0. It is where the function crosses the y-axis. So in this graph, we have 3 x-intercepts and 1 y-intercept. There can be multiple x-intercepts, but a function can only have one y-intercept. The intercepts are points and written as an ordered pair. Now let's talk about positive and negative intervals. Positive intervals are where y is positive. It is where the function is above the x-axis. So you can see we've got 2 positive intervals here. Negative intervals are where y is negative. It is where the function is below the x-axis. So here we have 2 negative intervals. Positive and negative intervals are written in either interval or set notation using the x values. Now let's talk about increasing and decreasing intervals. Increasing intervals are where y is increasing. It is where the graph goes up from left to right. So on this graph we have 2 increasing intervals where the graph from left to right is going up. Decreasing intervals are where y is decreasing. It is where the graph goes down from left to right. So we have 1 decreasing interval between our 2 increasing intervals. Increasing and decreasing intervals are written in either interval or set notation using x values. The last key feature we're going to talk about is maximums and minimums. The maximum is the highest point on the graph of a function. The minimum is the lowest point on the graph of a function. There are 2 types of maximums and minimums. The first is an absolute maximum or minimum. This refers to the entire function. So let's go back to our graph and take a look at how this looks. So we have an absolute minimum here because this is the absolute lowest point on our graph. There is no point on this graph that is lower than this. However, there is no absolute maximum since the graph goes to infinity. Now, the other type of maximum and minimum is a relative max or min. This refers to a specific interval or neighborhood within the function. So here we do have a relative max that is located here because we increase to this maximum point and then we start to decrease again. So in this little neighborhood of the graph, we do have a maximum, and it is a relative maximum. The maxes and mins are points and written as an ordered pair. So now that we've talked about several of the key features, let's identify a few with some examples. So taking a look at this example, we're going to identify first the x-intercepts. So we're going to look along the x-axis and find the place in which the graph crosses the x-axis. And that is at a point, -2, 0. Same thing for the y-intercept. We're going to look at the y-axis. And where does it cross the y-axis? At 0, 3. Now our domain, we have two ways that we can notate it, in interval and set notation. Our domain goes from -4 to 2 on the x-axis, and we include both sides. And in set notation, it would be written as this. The range, we look at our y values. So from bottom to top, we have -3 to 6. And again, we include the ends because we have closed dots on both the bottom and the top. And in set notation, we use this. Now the maximum is located at a point, the absolute top of the graph that's no higher than any other point, that is higher than any other point, is the point 2, 6, and our minimum is located at -4, -3. Now, positive intervals, we are going to look at our x values for this. So we're going to go from left to right. So from -4 to 3, the graph increases, but it's not positive everywhere. Where does the graph cross the x-axis? It crosses at our x-intercept, -2. And from -2 to 2, it is above the x-axis, so that is our positive interval. Now you'll notice in interval notation here, I have not included -2, because what is our y value at -2? Our y value is 0. 0 is not a positive number. It's also not a negative number, so we cannot include -2 itself. And here's your answer in set notation. Our negative interval is the other side of our x-intercept, -4 to -2. That's where we're below the x-axis. So we include -4, but again, we do not include -2. For this example, our x-intercept, we do touch the x-axis at -2, 0. Our y-intercept is at 0, -1. That is where we cross the y-intercept, or we'll cross the y-axis. Our domain, our leftmost x value is -7, but we don't include it because we have an open dot. Our rightmost value is 6, and we include that because we have a closed dot. Our range, our bottommost value of our y's is -9, and our topmost is 0. And we include both ends because we do touch both of those y values with our graph. Our maximum is located at the point -2, 0. It happens to be our x-intercept, but that is the top of our graph. The bottom of our graph is at -5, -9. We are increasing from -5 to -2. Again, we use x values here. Now, you'll notice that we do not include -5 or -2 because we are going from decreasing to increasing. At -5 itself, we are neither increasing or decreasing. We are flat at that point, so we do not include it. Same goes for -2. We are decreasing in 2 spots, from -7 to -5, and then from -2 to 6. So we're going to write that as 2 intervals, and we're going to join those 2 intervals by using the union symbol, which is just a U. You can also write it as 2 sets of inequalities. -7 is less than x, which is also less than -5, and -2 is less than x, which is also less than 6. For example 3, our x-intercepts, we actually have 3 of them. We cross the x-axis 3 times at -2, 0, at the origin, 0, 0, and at 3, 0. We have only one y-intercept, and that is also at the origin, 0, 0. We have a positive interval where we're above the x-axis from -2, excuse me, we need the domain. The domain is negative infinity to positive infinity, which is an arrow on the left and an arrow on the right. One arrow is pointing down, the other is pointing up, so our range is also negative infinity to infinity. Now our positive intervals. We're above the x-axis from -2 to 0, and we're going to union that with 3 to infinity. We can also indicate it using set notation. Our negative intervals are where we're below the x-axis from negative infinity to -2, and also from 0 to 3. Now let's talk about our end behavior. Let's start on the right side. The right side is where x is going to infinity. Because our arrow is pointing up, f of x is also going to infinity. On the left side, as x approaches negative infinity, our arrow is pointing down, so f of x is also approaching negative infinity. In example 4, our domain. We have an arrow on the left, we have an arrow on the right, so our domain is negative infinity to positive infinity. Our range, we have an arrow pointing down and an arrow pointing up, so it's also negative infinity to positive infinity. We have a maximum, but it is not an absolute max, so there's no maximum if there's not an indication as to either we're talking about absolute or relative. Assume we're talking about absolute. There is no absolute maximum. However, there is a relative maximum at 0, 0, because in the neighborhood, we do top out at a place. Because we have an arrow pointing down, there is no absolute minimum, but we do have a relative minimum at -4, -8. Now, increasing intervals. Where is the graph going up? And use your x values to do this. So we're going to start at the left. We're decreasing first, but then we start increasing at x equals -4, and we increase until we get to 0. For our decreasing intervals, we have 2 of them, from negative infinity to -4, and from 0 to infinity. Our end behavior, we're going to start on the right side. As x approaches infinity, since the arrow is pointing down, f of x goes to negative infinity. And as x approaches negative infinity on the left, f of x is pointing up, so we're going to infinity. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.